for this problem, I want to focus on the right triangle first. It's the one I'm highlighting in green. What I notice is that I have a right angle, which we know is 90 degrees. I also know that that green angle is 40, meaning that the angle down here must be 50. Now looking at the left triangle, its third angle must be 90 degrees because it makes a linear pair with the already given right angle. Furthermore, when I compare the two triangles, I have two angles that are 90 degrees in both, and then two green congruent angles in both, meaning 50 degrees must be congruent to the blue angle. So now that I've marked everything I can with the pictures, I need to start coming up with some equations. And since I have both values x and y, I must have two equations. For two variables, you need two equations. My first equation will be setting the green angles equal to each other, since I know that they're congruent. So I get 12x plus 4y equals 40. My second equation will be setting the blue angles equal to each other. I get 17x minus y equals 50. Now there are a number of ways that you could solve this. You could solve the second equation for y and then plug that value into the first, or you can add or subtract the equations. I'm going to show you what it looks like if you add or subtract the equations. For the first equation, I'm going to alter this a little bit by dividing through by 4 on both sides. So I get 3x plus y equals 10, because I took the whole equation and divided both sides by 4. You'll see why I chose 4 in just a moment. I'm going to leave the second equation how it is, because what I end up with is a positive y and a negative y, which, when I add the equations, will cancel. Thus I get 3x plus 17x, which is 20x, equals 10 plus 50, which is 60. I can solve for x and find that x is 3. To solve for y, all I have to do is plug the value for x into one of my equations. For example, 3x plus y equals 10. And I find that y must be 1. So my final answer is that x equals 3 and y equals 1. Hopefully you found the same solution. There are a number of ways that you can go about solving for x and y, but as long as you found the same values, then you're doing well. Okay, last example. And this is more for fun if you want to do it. But given the shape below, I want you to provide an informal argument as to why quadrilateral ABFE, so make sure you look at this, ABFE is congruent to quadrilateral CDEF. Take a moment, think about it, and then resume the videos when you're ready to listen to what they have to say. So remember, to prove congruent shapes, I want to show that all the sides, all the corresponding parts, both sides and angles, are congruent. Well, I can see that sides are congruent. We have AB congruent to CD. We have AE congruent to CF. We also have BF congruent to DE. And lastly, I know that EF is congruent to FE, and this is by the reflexive and symmetric properties. Actually, you can just write reflexive, because that's really all it is.